continuing on with our lesson on piecewise functions, we are going to be looking at how to graph the function. Of course, that logically makes sense. Now that we went from function to graph, we're going to go in reverse, graph to function. So the first thing that we want to do is write our f of x here and make it equal to that curly bracket that'll include it all. Now, it's kind of relative depending on the person, but I always like to start with my parameters. So what are the two parameters here? In this case, we've got a function that goes from negative infinity up to 0, but it doesn't include 0. So that first part there is going to be if x is less than 0. That's that very first part that we're dealing with there. That means the other part is going to be if x is greater than or equal to 0. Because remember, our domain for our function has to represent all the real numbers. So if it's x is less than 0, the other one has to include 0 and everything past it. The next thing we want to do is look at writing what these equations are themselves. So because we have straight lines here, we can write them in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where b is our intercept and m is our slope. So let's start there. With this very first line, it intercepts the y-axis, or that y-intercept is at 3. So we know it's going to be a 3 plus, and then we just need to figure out that slope. So I can pick any 2 points and count. Here we've got up 1 over 1, up 1 over 1. So our slope there is 1. So we can either write 1x or just an x. So x plus 3 is our line here, all the way up to 0. But once we reach 0, we switch to this function. And what's the y-intercept on this new function? Well, the y-intercept is -1. And what is our slope? Well, we go up 2 over 1, up 2 over 1. So our new slope is going to be 2x. So that's as simple as it is. First, start by writing your parameter, and that'll help you decide how many equations you need. And then you are going to write your equations in slope-intercept form. Now, as you move on later into math, you might see that piecewise functions aren't always going to be these straight lines here, and you can't always do slope-intercept form, but you will always write that equation. So that's kind of, in this class, we are only going to have straight lines, so we'll write them in slope-intercept form if we do, but in the future, you might see other lines. So let's take a look at this next one. So let's write a piecewise function for this graph. So remember, we want to start by writing f of x equals and our curly bracket. Then step 1 was find our parameters. So this first one looks like it goes from negative infinity to 0. And remember, those parameters are x values. So we go from negative infinity to 0, and we stop here at 0, but we include it. So this first one is going to be if x is less than or equal to 0, because that's everything from negative infinity to 0, including 0. And that means our other one doesn't include 0, but is going to be everything greater than 0. So if x is greater than 0. Those are the two parameters. Now, all we have to do is write those lines that are associated with it. So remember, slope-intercept form, y equals mx plus b. So always start with that b. In this first one, we have a -1 for our b. And then our slope is going to be down 1 over 1, down 1 over 1. So we're going to have a negative slope. So the equation for this first line here is going to be -x minus 1, or that expression there. Once we get to that 0 and we go past 0, we're going to look at this new one. Now the y-intercept on our new one is a 2, and then our slope is up 1 over 1, up 1 over 1. So that'll just be an x. And there you go. That is how you write a piecewise function. So remember our 2 steps. Step number 1, write your parameters for your x, and that'll tell you how many equations you have to write. And step 2 is write the equation. And always, if you have a straight line, try to use your slope-intercept form, because that'll be the easiest. Take a second to review over this, review over the previous videos, and we are going to move forward and talk about how we can use piecewise functions in the real world by looking at some application problems. So check out the next video on applying piecewise functions in the real world.